So this is going to be a talk on the use of evidence in games and mechanism design. Part 1 is going to be more on games and end with mechanism design. Part 2 will continue with Elchanan tomorrow, right? So originally I was supposed to be here at the end of the day when you'd all be awake, and so now I get you instead, at least the people coming from abroad, all jet lagged. So you'll probably give me an easier time. So to start with, I want to convince you that studying evidence is a worthwhile endeavor, evidence in economics in general. A major focus in economics for the last 40 years probably has been on asymmetric information. And the question there is, how do agents convey, or how do we elicit from them information that they have? It's been done in various methods, using cheap talk, for example, using costly actions, signaling, etc., and in mechanism design, auctions and so on, and using evidence, monitoring, etc. But I would like to emphasize that evidence has gotten the short end of the stick in terms of the quantity of work that's been done, and I'd like to encourage more of it, and hopefully this talk will convince you that there's something worthwhile to do. In particular, evidence plays an important role in many different environments. If you think about any activity you do in which there's asymmetric information, you usually invest some effort, and sometimes even with no effort, you get some information about the issue that concerns you. So, and how do you get that information? It's presented as a form of evidence. For example, you can test a car if you're buying a car. You can investigate the project that an entrepreneur is starting. You can interview an employee, a potential employee. You can examine the historical behavior of a politician to see how often the person shows up, which gives evidence on their tendency to behave, and so on and so forth. Okay? The issue of evidence in general can be looked at in many different perspectives. First of all, you can have one agent and a principle, or you can have many agents. There may be costs in presenting the evidence, or in receiving the evidence and understanding it. And and there may be games. You can think of games where there's no commitment power by the principal, or you can think of mechanism design, the focus of this school, where there is a commitment power. Okay. I'm going to be beginning by discussing evidence in games. And you might ask, why am I discussing games without commitment if this is a summer school in mechanism design? First of all, I don't think that the summer school is that narrowly defined. But to use this as that definition as an excuse, games have so far been studied more extensively in the context of evidence. So it sets a good backdrop in that sense. And furthermore, as you'll see at the end of today's talk, hopefully I'll get to it. Elchanan wants me to. And if not, then he'll begin with tomorrow results on the relationship between games and mechanisms, when there is value to commitment, when there isn't, and so on. And those results will show the benefit of understanding the solution to games. So let's get down to the brass tacks and start asking the simple question: how do we model evidence? So we have types, and a type is going to differ in two dimensions. A type is going to describe the evidence that that type has. So an individual will have different types, and their type will specify the evidence they have, what they can prove, and their type will specify all the other usual things that a type specifies: the value of the object to them, to the seller, etc., to them, to the other side, etc., etc. So, and we're going to be using a notation of mu as a prior over the types. So E of t, or script E of t, will be the evidence that t can present, and V of t is what we usually think of it, as all the usual aspects of a type. So what is E? Let's define carefully what the evidence structure is. So we're going to start with a set M of possible hard evidence messages. These are all the pieces of evidence that someone might be able to present. The evidence that a type can present will be a subset of that. So each type will be able to present a subset of the available pieces of evidence. Okay? And the type can present one of the messages. Now you might ask, why not more than one? I will be getting to that in a second. Presenting a piece of evidence M will mean that the type is one of those who can present M. So equivalently, we can think of, when I present the evidence M, I'm proving to you that I'm a T, which is in the set of all T primes, all the types, that have that message available. So for example, if I wanted to prove to you that I can tap dance, then I could stand here and start tap dancing, and I would prove to you that I'm one of the people in this room, or in the world, whatever, that can tap dance. I won't try, because I can't. But if I could, then that's a way to prove to you that I'm one of those people. If I could sing as well, then I could choose to sing, and I'll present the evidence that I can sing, and then I would prove to you that one of the individuals who can sing. So we can identify a message with the subset of types that can send that message. Later, therefore, instead of having M as B, the set of messages, we'll think of it just as the subsets of T. Okay? That'll be a convenient simplification that will come later. But for now, because I think it's easier to grasp the basic ideas, we're going to think of M just as really a set of pieces of evidence, dancing and singing, rather than I'm one of the set of people who can dance, or I'm one of the set of people who can sing. Okay. So why not enable presenting two messages? We're going to, if the environment permits that, sometimes you might think it's not possible to both sing and dance. I can do one or the other. So if it's possible, then we will add a message M that corresponds to sending both messages. In other words, the message M will be the set of types who can send both the messages I can sing and the message I can dance. Okay. Now, an important assumption that you should keep in the back of your mind that we're going to be making repeatedly isn't necessary for all models, isn't even necessary for some of the results I'll present and talk about, but is very convenient to work with, is that there is some message that corresponds to sending all of the messages that you have. So just like here, I said there will be, if you can both sing and dance, and there's time enough and patience enough to hear both messages, then there is a message that corresponds to both. Here I'm making the stronger assumption that there's a message that corresponds to all of the messages that you can send. Some M star that corresponds to everything that you can send. Okay, and we'll denote that M star of T in the future. For now, it's just for a particular T, so there's no need to define that. Normality, this assumption is called normality. It was first, I forget the name that it was introduced under by Bart Lippmann and Dwayne Seppi, and then it was developed further by, or used further by Bull and Watson, and they called it normality, so we're sticking with the latter term, which is the more commonly used one. So normality assumes that you have such a message. What does that mean in terms of reality? It means that there's no limits on your ability to present, and there's no limits on the ability of the other side to absorb. Okay?
Is that really any stronger than the original assumption you made on the fourth line?
No, if I assume that this is true for all possible pairs, then I get this. Okay? And in fact, this is weaker than assuming it for all possible pairs, since I'm only assuming it for all of them. Okay? So I meant stronger than just assuming it for one pair. Okay. So is it a realistic assumption? Well, it depends on the environment. There are environments where there are limits. There are environments where there are not. It does make life a lot easier in the analysis, so we will be assuming it typically in this talk. But I'll give an example, not an example, I'll mention a paper. If there's time, I'll discuss the example further, which uses a model where there isn't, where this assumption is not satisfied and shows the implications. Okay. Most of what I'll be talking about will fall into a class of games called disclosure games. In these games, there's an agent who wants to convince a principal that his value is high. Notice all types of the agent want to convince the principal that the value is high. I'll be repeating this type of assumption later. There's the assumption here implicit in that statement is that the agent's preferences are type independent. All the types agree. I want to prove that my value is high. The principal wants to know the true value of the agent. So you could think of a buyer-seller or an employee and so on, or an entrepreneur. There's lots of environments, which I mentioned earlier, where evidence plays a role, where this is a plausible assumption. So more formally, an agent is going to be presenting evidence to convince the seller of his value, V of t. The principal is going to choose an assessment A, which is going to be a real number, and his payoff is going to be a loss depending on how accurate this is. The farther away this A is from the true value, the bigger the principal loss, the bigger the principal's loss. For example, we could assume that the principal loss is quadratic. The quadratic model is convenient because then it's very simple to solve in the sense that the optimal strategy for the principal, given some beliefs about the agent, is just to take that expectation as his assessment, okay, as his action. Okay? And as I said, the agent's preferences are type independent. The utility of the agent does not depend on its type and is increasing in the assessment of the principal. The better the principal thinks he is, the happier the agent is. For example, we could just normalize it to be UA of t is equal to A. So this is going to be, it's not the only model, obviously, using evidence, but it's going to be a typical model underlying a lot of what I'm going to talk about. Okay, so the seminal model of evidence, at least in economics that I know of, was developed by Grossman and Milgram. In this model, there's a seller who has a certain quality, and he has evidence that he can prove anything that's true. So he can prove his exact quality, or he can say his quality is in some interval that includes the true quality, or you can say that it's any sub-collection of qualities so long as it includes the true quality. So evidence, as is clear from what I'm saying, has to be correct, and that was implicit in the way I modeled it so far. And the seller wants it to be thought of as having the highest possible quality. And the result is that in equilibrium, the value of the agent will be revealed. Why? The highest type will prove, of course, that he's the highest type. Therefore, unless the other side already believes that it's the highest type about everyone, okay? But that won't be a correct belief, because then no one will present evidence in that case, and it won't be a correct belief to think that everyone has the highest type. So the seller's belief is not going to be, unless there's evidence presented, that it is the highest type. So the highest type will want to present, the highest quality will want to present as evidence that he's the highest, and then it will unravel. This is a standard result, most of you know it, but just reviewing it. The problem with this result is its implication is we don't care about asymmetric information, we've solved the problem of asymmetric information, all of us can go home and we're out of a job. The reason that that's not a concern is that this isn't a very plausible environment. There are lots of reasons you might think that this is not the situation that we are in. Nevertheless, it does give us a useful benchmark, because as usual, when we have an extreme result, we know then what assumptions might we be interested in relaxing to get an interesting environment, to get something that doesn't have this complete unraveling feature where asymmetric information disappears completely. So Ron Dai in 1985 and Jung-In Kwan in 1988 improved and developed that model, considered a model where the seller has perfect evidence, as in the Grossman-Milgram environment with some probability, and otherwise has no evidence. Okay? So Q is going to be the probability of having evidence, and lambda is going to be the probability distribution over values. In a minute, I'll translate this to the model I talked about before, what are the types and so on, just to make it very concrete. But this is the way that they describe the model. There's going to be evidence with probability Q, and a prior distribution over types, over values, which is lambda. Okay? What do we have in this case? Now we're going to have partial unraveling. Okay? The reason we're going to have partial unraveling is that the low quality types will prefer to pool with the no evidence types. So some types have no evidence to present. If I'm the bottom of the barrel, then I prefer not to present the evidence and make believe I'm unlucky, I didn't have any evidence to present, and thereby I'll be thought to be a slightly higher value. What exactly will the threshold be? Well, imagine that the threshold V star is the belief about the seller when no evidence is presented. Then clearly any type who has a value which is less than V star won't present evidence, because they'll be doing worse. And any type who has value greater than V star will present the evidence, since they're doing better. Okay? So in equilibrium, what's V star going to be? It's going to be the expectation. Who's not going to present evidence? Those with a value less than V star, and those who have no evidence. So it's going to be the expectation of the V, subject to the fact that T has no evidence or it's less than V star. Okay? One can show that this solution is unique for any probability distribution, and therefore in equilibrium we're going to have a V star like this. Types with values above will present their evidence. Types with value below will pool with the no evidence types. Okay? And we'll have partial unraveling. Okay. Just to get the notation clear, I'm going to translate this story into the notation that I used before. So what's the set of types here? It's the possible actual values, and either you don't have evidence or do. So it's the cross product between values and your evidence state. The probability distribution over types is going to be the probability that you have value x and have evidence is going to be q, because it's independent, as assumed in that model. With probability q, you'll have evidence. And then the distribution over values is lambda of x, has the probability of getting value x is lambda of x. And the probability of having value x when you have no evidence is just going to be 1 minus q lambda x. The value is just going to not depend on the evidence, as I said, independent. It's just going to be x. The evidence you have in terms of the ability to present evidence, if you have type value x and do have the evidence to present is either you present x or you present nothing. Okay? So the two pieces of evidence you can present are my value is x or I have no evidence to present. Equivalently, if I think of this in terms of the subsets of the types that I can prove that I am, we could say that the evidence structure is a type who has evidence and is a value x can either prove that that's his type, okay, can prove his true type, or pool and say that he's one of any possible type. Okay? And this should be x. This is t. This is t, which is equal to x1. Okay? And if he has no evidence, then he can only present no evidence, and then the only thing he can do is pool with all possible types. Okay, this model that I just finished describing the basics of in the solution equilibrium is a workhorse model in accounting in particular, but in economics more generally. There have been a few very nice recent there's tons of contributions. I should emphasize this isn't a comprehensive survey. This is a biased selection to demonstrate a few insights that have been developed in the literature. Okay? So a few recent contributions that I happen to like, that I'm biased about, are one of Shin in 2003, Econometrica, one by Ilan and two co-authors, Acharya and Peter DeMarzo, in the AER, and a paper by Elchanan and Bart Lippman, whom, as I said, I don't think I said this actually in the first slide, so let me restate something from the very first slide. The work here has been a very long-standing project with Elchanan Ben Porat and Bart Lippman, and I'll be presenting a model of ours about this as well, which is currently being revised for the review. Okay, so in Shin's model, he shows that if we use the die evidence structure, then strategic disclosure, in contrast to unavailability of strategic disclosure, so an environment where you have strategic disclosure, will lead to stock price behavior which is consistent with evidence. And in particular, stock prices variability will be higher after bad news. Equivalently, it will be higher after low prices. Okay? I'll sketch that model very quickly. Ilan's paper shows that in such an environment, you can have clustering of news after a bad news is provided, but not clustering after good news is provided. So if somebody provides bad news, if there is bad news provided, then you will see a lot of additional news being revealed. Whereas if good news is provided exogenously, then you'll see less news provided, less evidence. Okay? This is a little abstract. I'll try to describe the models in a bit. Okay, so let me talk about Shin's model first. His model is much richer and has both models that I'll be describing are much richer than the way I'll be describing them. They have many more results. I want to highlight one particular result using a very simplified, pared down, and I hope Ilan doesn't think overly simplified example. Okay, so in Shin's model, I'm going to assume that the firm has two values, high or low, and there's going to be two periods. The manager is going to observe the true value with period Q in the first period, and if he observes it, he can reveal it, exactly as in the die model. And the second period, the firm's value will be publicly observed. Okay? We're going to compare two types of equilibrium. One where the manager, who wants to be thought of as having a high-value firm, strategically reveals H only if it's observed. Okay? So if he observes a high value, of course he'll reveal it, because that's the best it could be, as in the unraveling. But he can strategically hide the low value, as would happen in this type of model. Or the information is exogenously provided. We'll consider these two environments and look at the equilibrium that happens. Okay? So let's first look at the strategic disclosure case. If a success is revealed, in other words, if the manager observes an H in the first period, then what's going to happen? He's going to reveal the H, and the price is going to be H in the first period and H in the second period. That's going to be the value of the firm. If nothing is revealed, then there's two possibilities. He didn't have evidence, or he had evidence that it's slow. In either case, the belief about the period one, about the value of the firm is going to be less than H, so you're going to have a lower price, and there's going to be uncertainty over the future price, because it either can be L or it'll either be L or H as being realized. Okay? So we see that lower prices are going to be followed by greater price uncertainty. So low prices lead to future price variability. Okay? That's when you have a model of strategic disclosure. Okay. Are there any? By the way, I should say, if there are questions, please feel free. Yes.
Well, who is the other player
This is a game, so there's no contract being designed. This is a game where there's a manager who wants, there is another player. It's the market or potential people who might want to hire this manager away. So the manager wants to be thought of by whoever is observing the environment to have a high value firm. And he wants to be thought about this, he wants this to be thought of him in the first period and in the second. In the second, he has no effect on what's going to happen, so that's irrelevant. Either the value of the firm is L or H, and he'll be thought to be either L or H. A manager who achieved an L or H firm, respectively. But in the first period, by strategically manipulating the information, he can be thought of as better than he actually knows he is, okay? And so the other player here is the market or other firms or anybody whom the manager wants to impress. His mother-in-law, whatever it is, whoever it is that he wants to impress, who has beliefs over the quality of the firm that he is managing, okay? And there's no contract being designed. There's no principal agent problem in the sense of a principal designing a contract. There will be in 25 minutes, I guess, if I'm giving a rough guess. Okay, so in this environment, what we're going to have is in equilibrium, the manager who can strategically disclose will reveal successes, and there will be no price uncertainty after high prices, high value firms, and will not reveal failures, and therefore there will be a lower price after a lower price, and after that there will be high variability. Okay. Now let's contrast this. I might go back to that in a minute, but let's contrast this with the case where there's no strategic disclosure, where this information either by law is forced to be revealed or is exogenously disclosed. Then what's going to happen? If there's high information, then the price will be high in both periods. If exogenously there's low value information, then the price will be low in both periods. And if exogenously there's no information, the price will be intermediate, and then there will be high variability of what happens in the second period. So either H is revealed in the first period, and then it's H in the second, or L is revealed in the first period, and then it's L in the second, or nothing is revealed, and then the belief will be the average of H and L, and in the second period, the truth will be realized, and it will be realized to be either L or to be H. So when do we have the highest variability of prices? Actually in the middle. We have low variability in the future after a high price, because high. We have low variability in the future after a low price, because it's low. And we have high variability in the future after a medium, the average price, because then the future is the truth is realized to either be L or H. Okay? Shin says that there's, this is outside my realm, I just read what other people say about evidence, says that there's documentation that the price variability is higher as prices are lower. So in other words, this environment with exogenous disclosure is not consistent with actually observed prices, whereas this environment with strategically disclosure is consistent with actually observed prices over time. Okay? Let me also mention, so just to kind of clarify the calculations that are involved in the equation that I wrote before. What happens if the agent, if the manager here doesn't reveal information? Then there are two possibilities. Either his value is less than the threshold value, or there's no evidence. What's the threshold value going to be here? There's only two. H presents and L hides. Okay? So what's the value, what's the expectation conditional on no evidence in this case? Okay? With probability 1 minus q, there's no evidence, and then you have the true expectation. The prior over H plus the prior probability of H times H plus the prior probability of L times L. That's the expectation ex ante, and that's the belief if there's no evidence. If there is evidence and the realization is low, then the person doesn't present the evidence, so you fall into this category of no evidence being presented. So when is there no evidence being presented? Either with this probability there's this, or with this probability there's nothing. So, and we have to of course do the conditional and divide by the probability of this event, and that's how we get the conditional probability of you being a low value or a no evidence type. Conditional expectation, yes. Okay. Now, it's easy to see that this is going to be decreasing in Q. So we see that the price variance is increasing in the asymmetry of information, right? Because what's the price variance? Either the price is going to be the prior, or either the realized price is going to be the prior or L. So there's two possible outcomes of Sorry. Let me repeat that. In the first period, after no evidence is revealed, this is the new prior. Okay? Okay? And then from this, we're going to have a realization, which is either this or this. Okay? And when do we have this realization? This realization is more likely the bigger is Q. Okay? So the variance is going to be increasing in Q, and therefore the variance is increasing in the as the asymmetric information grows, because Q is the probability that I will have evidence. And this also, Shin, draws a connection between this. It's a much more involved connection, so I'm not going to go through it, but draws a connection between this, because we don't observe asymmetry of information. But he draws a connection between asymmetry of information and types of firms, and argues that the evidence shows that with the types of firms that have higher asymmetry of information are those that have higher variance of prices. Okay. I'm going to be optimistic and imagine that I can also present a version of Elon's model. In this model, so this is another application of the idea of disclosure, and it shows the connection between disclosure and relevant environments. Okay. So there are going to be 3 stages. In the first stage, with probability Q, a manager privately observes the value of the firm. Now the value of the firm is going to be 3 possible numbers, -1, 0, or 1. Okay? And let's assume that the prior is equally, over those values is equal. And if he observes it, he can decide to reveal it or not. Okay? After he decides whether or not to reveal it, a public signal is going to be observed. The manager has no control over the public signal. The public signal is going to be plus, good news, if the value is 0 or 1. The public signal is going to be minus if the value is -1 or 0. Okay? And then, in the third period, the manager can reveal the private information that he had here if he hasn't yet revealed it. Okay? So if he has the information and hasn't revealed it, he can now choose to reveal it. The market decides the value of the firm at the end of each period, and the manager cares, this is again a gross simplification, cares lexicographically about the belief of the market at the end of the third period, and second order lexicographically about the belief at the end of the first period. Okay? We could make it a more continuous model and not have it be lexicographic. The proof is a little more involved, and now I can give a simple argument. Yes? No. Yes. If
with equal probability.
With equal probability. Okay. Yes. Thank you. I should have said that explicitly. And was that your question as well?
That was my question.
Okay. So what are we going to see? Let me tell you what the result is. The result is that the manager is going to reveal more information after a bad public signal than after a good one. In other words, after bad public signals, you're going to see more information. After good public signals, you're not going to see more information. This is the data that they claim in the paper is prevalent in the actual stock market. Okay? So let's see what's going to happen here. So in the first period, what's the manager going to do? He's obviously going to reveal a 1, because that's the best that can happen, and he's always going to hide a -1, because that's the worst, and the beliefs can't be worse than that. Will he reveal a 0? Well, the answer is no, because what he can do is he can wait to reveal it later. If the signal is plus, then it's better to wait, because if the signal is plus, then the beliefs are going to be some average between 0 and 1, a strictly positive number, and therefore, if you reveal 0, he's proving that he's worse than what he'll believed to be. If, on the other hand, this public signal is minus, then the belief is going to be some average between -1 and 0, and therefore, if he reveals a 0, then it will improve the beliefs about him. So after plus, he will hide the signal. After minus, he will reveal it. And therefore, in the first period, he'll also prefer to wait for later. Okay? If instead we didn't have any ability to time the disclosure, and the disclosure has to be after, there wasn't this ability to reveal something in the first period, and the disclosure had to be after the public signal, then what would we see? We would see that there'd be a disclosure of a 1 after a plus, and a 0 after a minus. So we'll see both after a plus and after a minus, we'll see public disclosure. So we won't have this phenomenon of more disclosure after bad news, which occurs when there's strategic revelation of information, but not when there's enforced or non-strategic revelation of information. Yep.
Sorry, if the signal is plus and the manager didn't reveal information in the first period, can't you immediately deduce that the person's signal is 0? Because if the manager had a 1 signal in the first period...
No, you can deduce that if he had a signal, that it is 0. But he's not presenting it, right? So he either, with some probability, he didn't have any signal to present. So you don't know for sure that he had a signal, and therefore your expectation is going to be strictly positive. Okay? The exact calculation is going to be along the lines of that V star T that I wrote before, but it's slightly more involved, and that's why I didn't write the exact calculation. But it'll be a conditional expectation based on either he didn't have evidence, and it's 0 or 1, or he did have evidence, and then it's 0 for sure. Okay. Yes? So the assumption here is, let me make it more extreme. The assumption is that the preferences are as I described them. The manager wants the market to have the highest belief over the value of his firm. Okay? He's not trying to manipulate the value in order to do some insider trading. He doesn't have he doesn't have friends to whom he wants to disclose the information and wants them to do better. The manager's goal is to maximize the beliefs over the value of his firm. So whatever other features that might exist which would drive a manager's behavior are assumed away.
But when maybe if it is your assumption, I can't understand if he has fairness that the marketplace will point a high price today and not tomorrow. Since if he just
And what? And
not in the future.
No, he cares about both periods. He cares about the value that they assign in all periods. Okay? So the way I describe, the market assesses the value at the end of each period. For simplicity, I'm assuming that he cares most about at the end, and lexicographically about this. Why did I do that? So that the proof that I gave would be just a one-line proof without even writing an equation. If you want the more general model, you're encouraged to look at the paper where they consider the case where there's a continuum of values, a continuous time horizon over which you can release information and over which public information is arriving, and where the manager cares about the expectation, an average, and possibly even a weighted average, over all possible periods assessments. But everything would hold, as I said, in this model if you assume that he cares 1/3, 1/3, 1/3 about this as well. Okay? It's just that then I'd have to write down some equations and I couldn't just give the proof the way I did before. Okay. So, and in general, in all of the disclosure games I'm going to be talking about, we're going to assume that you want to be thought of as the high value. As I said, that's an underlying assumption in these models, and we're assuming away other features that you might have, other reasons you might want to add. For example, there may be some probability that the person's honest and wants to actually convey the truth. We're not assuming that. There might be insider trading. We're not assuming that. All of those features are being ignored to focus on a very narrow point, driven by, when you want to be thought of as high, how will you manipulate disclosure of information?
Insider trading could lead to preferences like this. You own
Could, but then you might want to manipulate the price in the first period to be low in order to buy, and then manipulate. So it would be, it could.
But in this lexicographic where you care mostly about the second period.
Yes, it's more right. With the lexicographic, it would be more. It would be possible, but since I didn't solve it, I don't want to take a stand. I'm not going to go through the model, but let me point out that Mike Fishman and Kathleen Haggerty have an application, again, to a stock market environment where they assume that that the evidence isn't normal. They're thinking of an environment where the government has to regulate a firm in terms of how much information or how it provides information. And the problem is that the audience, the readers of the prospectus or whatever the description is of the mutual fund, say, that they're buying, or the bond, etc., don't have a lot of patience and can only read a limited number of pieces of information. Okay? The minute that the audience has a limitation on how much information it can read, that's going to violate the assumption of normality, and they explore that in a different model than what I've described, but with the same ideas, where a manager is trying to manipulate the beliefs of the audience about the value of the firm, but the audience has bounded rationality in the sense they can only absorb a certain number of facts. Okay? Let me mention a few other classic papers, just so I said it's not a general survey, but at least to mention a few real classics. Verrecchia also has a model where you don't get complete unraveling. So I presented the die model because it's what I'm going to be working with and what Elchanan will be talking about a bit tomorrow. But there's another model which is very common, where instead of there being a probability with which you don't have evidence, there's a cost to presenting the evidence. Structurally, the outcomes are the same, but the analysis is a little different, and in particular, the analysis of welfare becomes very different, as I'll explain in a second. In Verrecchia's model, because there's a cost to presenting evidence, again, a low type won't present evidence because it won't be worth the cost to actually do so. Okay? So there'll be again a threshold. The lower types will not present evidence, and the higher types will, exactly as in the die model that I presented. Okay? So the structure of the equilibrium is going to be the same. The parameters that drive the equilibrium are different. In the die model, it's the probability of having evidence, and in the Verrecchia model, it's the cost of evidence. The reason that I find the die model at least easier to work with is not because it's easier necessarily to solve, but because when you look at welfare, you don't have to ask, do I think of the cost of the person presenting the evidence as a relevant cost or not in terms of welfare calculations? And then that issue that you might say, the first best might be that they reveal the information, and then we have to take into account that cost. And this complicates, in my view, the analysis of the welfare because it brings in something which is really different in terms of the welfare. But it's an interesting model, and there's a lot of work that's been done using that. Joe Farrell has a very old and classic paper on the revelation problem. In fact, it's very similar to the die model, a predecessor of the die model that got published in a volume that has been, I think, more or less forgotten, and therefore the paper isn't very visible, but it's a nice one. Matthews and Postlethwaite, Okuno Fujiwara, Postlethwaite, and Suzumara also are interesting classical papers because what they do is they say, well, what happens if we consider a different evidence structure? These are the initial papers that started to say, well, there's die evidence, there's Verrecchia, here's other evidence structures, let's explore them. Okay. Now I'm going to talk about a paper. BDL will refer to a Ben Parat Dekel Lipman, a paper with Bart and Elchanan, which is another example of the effect of introducing strategic disclosure. But we're going to add, in addition to the strategic disclosure, a strategic choice of what project to invest in. Remind me, what's the time? An hour or an hour and a half?
Until 11, so you have 15 minutes.
Okay. Excellent. Okay. So we're going to consider an agent who's choosing in period 0 among projects that have uncertain outcomes. The choice of project is not observed. You can think of this as an entrepreneur who can argue what he's going to do to a venture capitalist, but actually what he does is not observed, okay? Only until later in the environment. Okay? The realized outcome is observed. Actually, the success of the project, what it realizes, is observed, but only with some delay at the end of the game. In the middle, the agent gets information that he can provide, so he gets evidence with some probability, just as in the die model, and he can choose whether or not to release it. So, at the beginning you choose, I'll be giving an example shortly, but at the beginning you choose between what project to engage in. After you've chosen the project, that project realizes its outcome. It's an uncertain project. It can be bad, middle, or high. Okay? Bad, middle, or good. At the interim stage, the manager may observe whether it's bad, middle, or good, and can then decide whether or not to observe it. Okay? The question we're going to ask is, how does this ability to strategically disclose information affect this choice in the initial period? Okay? The agent is going to care about the final outcome, in other words, the actual realization, because that's going to be the belief about him in the end, but also about the belief at the interim period when he's presenting. So as before, you can think of this, let me jump to a couple of stories that correspond to this. The agent's the manager as before, and the observer's the market. In the long run, the outcome of the manager's actions are observed and determine the firm's value, so the outcome is realized. In the short run, the manager can release some private information about what's happening in the firm, and he can reveal and he can choose that strategically. Okay, he can reveal more successes than failures, for example. And the manager's combination is going to be a combination of the value of the firm in the short run based on the information released or not released there, and the information at the end of the game.
So the action is never revealed?
The choice of project isn't revealed. Okay, it doesn't. At the end, it doesn't matter, and in the mid, it's because the value of the firm is determined by the realization of the project, and in the middle, it would greatly change the story that I'm telling. Another example would be an entrepreneur trying to get a project funded by a venture capitalist, or a division that wants the manager to approve the project that is proposing to engage in. Okay? At some stage, the project's going to be reviewed, and if the evidence so far presented isn't good enough, then the project will be canceled. But there might not be enough evidence, and then the manager or the entrepreneur has to decide, well, there isn't evidence, do I pull the plug on this project or not? And the question is, how will this affect the venture capitalist has to decide whether to pull the plug. And the question is, how will this affect the entrepreneurs and the division's decisions about what projects to engage in? Okay? A final example is that the agent is a politician, okay? And the politician is engaged in some project, say healthcare, and the actual question of whether that healthcare project as defined at the moment is good or bad will only be realized after 20 years. In the middle, there's some evidence. And the incumbent may have evidence that he can present. And in fact, you might think that in this environment, the challengers may have evidence that they can present, as we see is happening a lot in the US. This side says, here's the evidence proving that Obamacare is good. And this side says, here's the evidence proving that Obamacare is bad. And you have both sides trying to present evidence. In the talk today, I'm going to talk only about the case where we have one side, namely the person who wants to be thought of as good as presenting the evidence. In the paper, we allow for both sides to present evidence, namely the person who wants to be thought of as good and some challenger who wants to prove that it's bad. Went wrong way. So first let's discuss the intuition and then see an example that displays the result for this case. Intuitively, it's obvious that, so I'm going back to the story again. The manager chooses a project. After the project, he gets information, evidence. The evidence can be presented or hidden. And he may get evidence. The evidence that he gets can be presented or hidden. And at the end, the actual value of the project is realized, is observed by everybody. So clearly at the evidence stage, the agent will present good information and suppress bad information. Where will the threshold be? It'll be a V star according to the equation that we had before, same basic idea. But if I know that I'm going to hide bad information, then what I'll have an incentive ex ante to influence the distribution of information, because I'll be presenting good information and hiding bad. Okay? So I'm going to distort my project choice. In what direction? I'm going to distort it to be risky, because by increasing the risk, I have better chance of being able to present something that's good, and if it's bad, I'll just hide it. Okay? I presented this. So let me present an example to clarify the model and that story about the risk-taking. So there's going to be two projects. The agent cares only about the beliefs at the middle stage. We could again have that he cares about the beliefs in the middle and at the end, and there'll be a slightly more complicated calculation which shows exactly the same as I'm saying now. Okay? So the agent will have perfect evidence about the project with some probability between 0 and 1. The two projects are F1, which gives a payoff of 4 for sure, and F2, which gives a payoff of 6 with probability of half and 0 with probability of half. Obviously, this is the better project, and this is the riskier project. Okay? The worse and riskier project. Okay? So we would like the agent to choose F1. The point of the paper, of this model, is to show that because of the ability to distort the evidence that's presented, he won't choose F1. F1 is never in equilibrium. Why is that? If F1 were the equilibrium, then what would the expected outcome be, even if no evidence is presented? Since in equilibrium the agent is choosing F1, in equilibrium everybody has to believe that even when no evidence is presented, the value of the project is 4. Okay? But then, what do you get if instead you're expected to choose F1, but you deviate to choosing F2? Then, if you have evidence, with probability of half, it'll be bad and 0. So you won't present it, and people will think you're choosing you're still in equilibrium that we're checking of F1. They'll think you have a 4. With probability of half, you'll have a 6 to present, and with probability 1 minus q, you'll have nothing and be thought to have the 4. Okay? So once again, what I'm trying to argue is F1 is not in equilibrium. Assume it is. If it were in equilibrium, then if no evidence is presented, you will believe to have a project which is worth 4. Okay? If you deviate and choose the other project, when you're lucky and have evidence and the outcome is good, you'll present a 6 and will be thought to have a 6. The market here doesn't care about the project. Okay? What they care about is the actual value that the project realizes. So if you get a 6, then the market is very happy. They're not going to say, oh, that's bad because it could have been a 0. Okay? You could think of a different model where the market would say, oh, that's a bad manager, he chose a bad project. That's not the environment we're considering. The environment is the market's beliefs are the value of the firm, and the manager here wants to maximize that value. So in that case, F1 isn't in equilibrium. There was a question. Yes?
Is it important that the second project is worse in 2 dimensions than the first, in the sense that it's riskier?
No, it's not in terms of the result in the paper is that it's the intuition, obviously, if this was 0 and 8 instead of 0 and 4, you'd get the same outcome. Okay? The point of the paper, though, is that then isn't an interesting example because what you get is that the manager, assuming risk neutrality, which is implicit in everything I've said, the manager is indifferent and everybody's indifferent between the two projects. So if they were the same in that respect, then this wouldn't be an interesting example because nobody cares. And if this were bigger, say it was 0 and 9, then you'd get the efficient outcome. So yes, you'd get the efficient outcome, fine. The point of the paper is to say this does lead in some cases to a distortion, and we characterize when it does exactly. This is an example of a distortion, of a bad situation where the manager will not choose the best outcome. Okay?
But you can contract in advance on sort of what the manager is supposed to do, sort of punish him for choosing that outcome.
Yes. Okay. So once again, as I said, this is about games, not contracts. But a natural question is, what would happen if there were contracts? The question then is what you would want to do with a contract. Many contracts with managers are designed to reward managers for good realizations, and the reason is because you want to incentivize effort. So to the extent that you penalize a manager for getting a good realization in a situation like this, to avoid him choosing this lottery, then choosing something that's risky and bad, then you're going to diminish his incentives to put effort in. Now that would involve a richer model where there's, in addition to choosing projects and manipulating that, also manipulating the effort. Okay, so there's other reasons you might not want to do that. The second reason is that while that's ex ante, you can think of that in if you allow for renegotiation, it's not very plausible, because who's going to write the contract that will disincentivize the manager from choosing this when this is the equilibrium? If you're thinking of the current owners of the firm, they also have stock in the firm. They also will benefit from the firm being thought to be greater in the intermediate run. So they will have the current stock owners, like the manager, actually could benefit from manipulation. Okay, so they're not going to want to sign the contract. The people who want to sign the contract are the people who are potential buyers of this stock, who really are unlikely to be able to write a contract which says, if you actually come out and present a 6, then we're not going to buy it at 6, even though we know that the value of the firm is 6. That seems a very difficult contract to materialize. So for two reasons, I think that this force will survive even if you add contracts, as long as you enrich the model to allow for renegotiation, to consider who is writing the contract and what their preferences are, and to allow for effort on the part of the manager. So if you made the model more realistic with contracts and in other dimensions, I think maybe not in full force, but still this aspect will survive. But yes, that's a very good point. The question, a natural question to everything I'm presenting is, what would happen if this were a mechanism design problem? Okay. 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 So the main result is that the agent engages in excessive risk-taking. The exact formulation of that is in the paper. And we also calculate a bound as to how bad the payoffs can be, and we show that they can be as low as 50% of the first best. Now, let me take make a parenthetical remark here, because oftentimes, not actually in the Hebrew University and certainly in this building, but oftentimes outside of this building, people would say, why do economists care about these lower bounds? That's what computer scientists do. So let me point out here, I'm not devising a mechanism and saying, here, I found a mechanism that can get to 63%, and therefore this is the mechanism that I think will be chosen. Okay? I'm not as critical of that as many economists, but that's not the reason I think this is worth doing. The question is this an interesting result? I say players engage in excessive risk-taking. If it then turned out that the payoffs are going to be at least 99% of the first best, yes, there's excessive risk-taking, but who cares? The excessive risk-taking is in a degree that's so small that it's not going to matter for anything. Here, we look at what's the worst-case environment in order to understand how bad this effect can be. Okay? And also, by understanding how bad it can be, we see when it is that bad. And by characterizing when, we understand when we have to be more concerned about the excessive risk-taking rather than less. In other words, in terms of the parameters of the model, what are the parameters that lead to this being a real problem, and what are parameters don't? Yes? No. The 50% assumes the worst case on the preferences and the worst case on the distributions and the worst case on the probability of having evidence. So there's three parameters. What's the set of distributions? What are the preferences, the weights you give on the two periods? And what's the probability of getting evidence? So if we take the minimum over all three, you get 50%. The paper has an exact equation which shows you how each parameter affects it. So you can do the minimum assuming the preferences are equal, but minimizing over the other things, and so on. Okay. Up. Yes?
Can you say why 50% as opposed to any other number?
Yeah. So of course, I hope yes, because otherwise I didn't understand the own paper. And if I click on this bullet, then we'll have a 2-slide proof, which I will return to depending on time permitting. Okay? So
What I meant was why 50% without the proof. Why? What's special?
no, yes. So you're asking for a nice clean intuition for what's special about 50%, and I don't have an answer for that. If I gave the example of how it's attained, you can get a feel for that, but that's not really the answer of why couldn't I find a better example which attains lower. And do you have I don't have a good intuition. The proof is fairly straightforward, but I don't have anything beyond that.
What's the maximum number of the state of how many state of the world do we have here? Like two, like as in the previous example, or like potentially infinite?
Potentially infinite, but in the worst case, it's sufficient to have 2 to develop the worst case. You can get it with more, but 2 is enough. But the model allows for any finite number of realizations and any finite number of projects. So there may be any number of projects with any distributions whatsoever. And the first question is, what bias will we observe? And the answer is towards riskier distributions. And the second question is, how bad can it be? And that depends on the distributions, but I can construct with 2 or more realizations that you get 50%. Okay, up until now I've been talking about a single sender. I'd like now to turn to point out that there may be multiple senders. What's the advantage of multiple senders? I'm not going to claim, and is Amir here? And there's a paper by Amir which argues that it's not general, and I'm not going to claim that it's general, that conflicting preferences resolve all possible, that multiple senders can resolve all possible problems that can arise. But I just want to point out that if there are multiple senders and they have different preferences, then we can get a separation result. By separation result, I mean the Milgram-Grossman unraveling, that you get full separation. You know exactly all the information. The asymmetric information disappears. You can get that with much weaker assumptions about the economic environment. Okay? So this is done both in the disclosure game environment, like I was talking about, and in other types of environments. So Milgram and Roberts show how the fact that you have many senders and they disagree about what they want, that can be taken advantage of to get a fully separating equilibrium, even if the senders don't have type-independent preferences like I assumed so far, and even if the receiver has limited rationality, so he isn't able to calculate equilibria and so on, and just and he can only work based on evidence that's presented, the conflicting preferences will lead to each side trying to prove their point, and then there'll be a lot more evidence revealed, and then the receiver will do better. Okay? Bart Lippmann and Duane Seppi, in the paper I mentioned before, which introduced the notion of normality under a different name that I'm not remembering right now, they showed that you can get it under different evidence structures. So here the focus was, let's change the preferences and let's change the rationality. Here the focus was, let's consider different evidence structures. So to give an example of the latter, consider a politician who wants to convince the voter that his type is high, V of t is high. Okay? The competitor, the challenger, wants the voter to believe that V of t is low. We're going to assume the following very weak evidence structure. If the true quality is V of t, then for any V prime not equal to, that should say V of t, the competitor can refute it. He can prove it's not V of prime. This is not a normal evidence structure because you can't prove that it's not. So let's imagine there are three possible values. I can be either 1, 2, or 3. And let's say that my true value is 2, okay? And the challenger, the other politician, can prove, if I say that I'm 3, he can prove I'm not 3. If I say that I'm 1, he can prove I'm not 1. But he can't prove that I'm neither 1 nor 3. That would be equivalent to proving what I actually am. So we're not giving the challenger the ability to present all the evidence he has. He can either prove I'm not 3, or he can prove I'm not 1, but he can't prove that I'm actually 2, in other words, that I'm not 3 nor 1. Was that clear? That's a non-normal evidence structure, the type that I said I'm typically not going to be assuming, but here's an example where we see that even with such limited evidence, we're going to get, because of the conflicting preferences, we're going to get full separation. Okay? What's going to be the equilibrium that enables? Not all equilibria have full separation, but there's a very simple one which does. The principle says the true quality, and the challenger proves that it's not that if he lies. Okay, so I say that I'm 2, and the challenger proves he's not 2. Okay, did I say that clearly? Okay,
Well, it's not quite. It's not. The challenger won't refute it if he lies and understates. Only you say.
So yes. The challenger will refute if he overstates, right? If the politician understates, which in equilibrium won't happen, but if the challenger understates, then if the incumbent understates, then the challenger will just smile happily and say, "See, he's really that low quality," rather than refuting it. Okay. Although it depends, we could just a second. Just a second. The slide says he will refute if he overstates, and I'm talking about that equilibrium. We could even have an equilibrium where the challenger refutes if he understates, okay? Because if we believe that, the question is, what are the beliefs off the equilibrium path when the incumbent has stated his type and the challenger has refuted it? If whenever there's a refutation, the belief of the population is that he's the worst possible type, then the challenger will refute even when the incumbent understates, unless he understates to the fact that he's the worst possible type. Okay? It doesn't matter. These are two different equilibria. One equilibrium is where the challenger refutes if he overstates. The other equilibrium is the challenger refutes if he understates. Either way, one equilibrium is the challenger refutes if he overstates. The other equilibrium is the challenger refutes always, except if he states he's the lowest type. Both of those equilibria involve truth-telling on the equilibrium path. And therefore, we'll get the full separation result, even though the incumbent has no information to present, that in this extreme version, and the challenger can only refute a false statement. He can't prove anything positive. Okay? So this is to show the power of having conflicting preferences between the person who wants what the person who wants to be thought as and the person presenting the evidence. If we add to this two players with evidence, we can even have more involved examples, as in the Milgram-Roberts paper, which you can look there to see the example. If time permits, I'll get to it later.
Maybe it's just worthwhile to further motivate, emphasize that the political context is exactly a context where you have serious limitations on the attention.
Yes.
So
Okay. So what Elchanan is emphasizing, is asking me to emphasize, is the realism of the assumption that the normality is not satisfied in a political environment. Because in political environments, if a politician were to present all the evidence, in other words, every single fact and statistic about Obamacare to the population, those thousands of pieces of data would not be looked at all. Okay? What you need to do is you need to present as a politician one or two pieces of data and hope it convinces people. So this is a plausible case where there's limitations on what can actually be presented by either side, the incumbent and the challenger. Okay. I would say that it's very hard to think of an environment where normality is satisfied, to be honest, because while I'm going to assume it because it makes life simple, as in all our models, we make assumptions that that make life simple. We had a department meeting at Tel Aviv yesterday, and I got into a rather heated debate with Leo Lederman about the value of models, and his point was that all the models are junk because all of them make assumptions that are obviously crap. And I'm not going to engage this audience and myself in that debate now, enough to have it once every few months, not more. So, and since I had it yesterday, that's it. But in general, I think normality is a good example, is an assumption which is a good example of a useful assumption, one that helps us understand what's going on, but is clearly not realistic. Why is it not realistic? The simplest example is this talk today. I keep skipping over bullets that I could push to show you the proof of the result, to show Stephen why it's 50%, which while it's not intuition, the proof is simple enough that it would convey, I think, what's driving it. And all of these things, which I could, are not, we don't have the time to present. So it's a typical situation that we don't have this ability. You were about to ask?
I guess one question is how drastically would things change if you didn't assume?
Normality. Okay. So in games, as I've been talking about so far, the answer is, well, you solve the game, there'll be an equilibrium like this, there'll be an equilibrium like that. It depends. And it depends on the environment. But excellent introduction, excellent question to lead me to the next. A natural question, now I'm turning to the mechanism design environment, and a natural question in the mechanism design environment is whether the revelation principle holds. Okay? And then the question is, wait a minute, what is the revelation principle when there's evidence involved? Okay? So there's been a lot of this, a number of papers about this, and the two main results are, if you assume normal evidence, then a simple version of the revelation principle, which I'm about to state, holds. But if you don't assume normal evidence, then it's a much more complicated environment. So whether or not it affects the optimal mechanism is a little more complicated to see, but to prove anything, already we're in a more complicated environment. Okay? And I'll try to give a sense of why this normality plays an important role in the revelation principle now. Okay. So first the result. The result is, without loss of generality, we can restrict to direct truth-telling, and while I missed the talks yesterday, I presume that that's something that everybody understands, direct truth-telling mechanisms. The addition here is we can restrict attention to direct truth-telling maximal evidence mechanisms. In other words, mechanisms where the agents only present their maximal evidence. Okay? So it's a one-shot environment. We don't need dynamic mechanisms, sequential mechanisms. We can restrict attention to a situation where we ask the agent their type. They present evidence that is maximal. Okay? In the truth-telling environment, they present the maximal evidence of their true type, and they announce their true type. And the principle, so each agent sends a cheap talk message about his type, and sends his maximal evidence. And the principal is going to be constrained by incentive constraints that make it incentive compatible for the agent to truthfully reveal his type and send his maximal evidence. So we'll have the incentive constraints of standard mechanism design, namely truth-telling, and additional incentive constraints of sending the maximal evidence. Okay? This is a bunch of papers which show various versions of the revelation principle. Green and Lafont are in a slightly different environment, so strictly speaking, it's wrong to include them in this list because they don't really deal with the same type of revelation principle, but they're the first paper which actually asked the question of what would a revelation principle be in a model with evidence, so they certainly deserve to be mentioned as originating the question. The model is a little bit different, so they don't exactly get this result. These three papers have versions of this exact same result. Okay? Let me point out, I'm not going to discuss this in detail, but it's convenient for later, that if you have type-independent preferences, meaning that the agent's type preferences don't depend on his type, as in, for example, a simple disclosure game where he wants to be thought of as the highest value possible, and the preferences are strict, in other words, there's no indifferences, okay, then there's no need even for the cheap talk message. Okay, we can get it, all we need is presentation of evidence. Okay, let me talk, before getting into that specific restriction, let me talk about and try to clarify what I mean by the revelation principle now. So the primitives are going to be the types T. Remember, a type is two things, the evidence they have and the other features, what I'm calling the value. A prior over the types, an evidence structure, which for any type says what subset of messages he can send, the actions that the principal can choose, and the preferences. The utility of the agent, which will depend on the action of the principal and his type, and the utility of the principal, which will depend on the action of the principal and the agent's type. Okay? In a direct mechanism, what do we have? We have the principal, the definition of a direct mechanism is, I ask the agent his type, and he makes some report. I don't have to ask. The agent makes some report about his type. The agent presents some evidence, and I choose some action. And the principal chooses some action, which in general can be a random action. A direct truth-telling maximal evidence mechanism, as I said in words, will be one where the principal is choosing a direct mechanism, so we're restricting attention to such mechanisms. He wants to maximize his expected utility, the utility of the principal, from what he gets. What is he going to get? He's going to choose according to the mechanism to which he committed. So he chose this, he committed to this function. He's going to get whatever type realizes. Okay, in a truth-telling environment, he's going to get the outcome that the mechanism specified for the actual type, given the message of the maximal evidence, the maximal evidence of that type, and when it's actually that type. Okay, so let me explain this again. The principal maximizes his utility function, which depends on his action and the type of the agent. Okay? We're looking at truth-telling environments. So in equilibrium, in the solution to the mechanism, the agent will be reporting the truth. So we take expectations over the agent's type. Okay? And since the agent is telling the truth, that's the type that will enter into the mechanism, and the maximal evidence of that type is what will be presented. Okay? Any questions about what the principle is maximizing? What are the constraints? There's the usual truth-telling constraint, and there's in addition the fact that the evidence presented has to be an incentive compatible. So what does the agent get if he sends the truth and sends the maximal evidence and tells the truth? He gets the expectation of what the principal, now the expectation is over the principal's actions. Okay? He's type T. He's reporting the truth. He's sending the maximal evidence of his true type. The principal is choosing according to this. We take the expectation over his utility from that action distribution, given his true type. What could the agent do instead? He could lie about his type, and he could send some other message, some other piece of evidence. So for any possible other lie about his type, and any other piece of evidence he sends, it has to be that his expected utility is greater. This is his actual type. This is the type he reports. This is the evidence he sends. This is what the the parentheses are wrong. Yes, this one should be here, sorry. As on that side, there shouldn't be a double here, it should be over there. So you get the utility of the action and your type. This is your true type. This is your reported type. This is your evidence that you send. This is what the principal would do. Your utility from that has to be less than what you get when you do what you're supposed to, tell the truth and send the maximal evidence.
Presumably, the principal will choose a mechanism which will force the agent to send maximal evidence. I mean, for some time, right? If you could always send 3 pieces of evidence and you send one, principal can see that you're not sending maximal evidence. You can be punished for that.
Yes, but let's say there's 3 people. One person can sing, one person can dance, and the third person can sing and dance. So if I just sing, have I presented maximal evidence or not? One type, sorry.
Some type. For some.
Right. We could get rid. So it's very easy. Well, sorry, it's not even that is true. In some environments, I'll clarify why I'm saying that in a minute. In some environments, we could restrict attention to the set of messages that are maximal for some type. Okay? In what environments? If we know how to punish the players. So if they have type-independent preferences, then whenever we get a non-maximal message, we could give them the worst outcome, because since we don't know what their type is, we just give them the worst possible outcome, and that would keep them in the worst payoff. Okay? But if it's not type independent, it's a slightly more involved situation because I don't know what type they are. So when they send me a non-maximal message, then I don't know which type they are. So let's imagine there's 2 types. Both of them can send the message 1, or the message 1 or the message 2, or the message 1 and 2. So both types can send the same thing. Okay? Type 1 wants a high action. Type 2 wants a low action. I see the message 1. What do? I don't want that to be sent in equilibrium, but I can't restrict it to. I can't rule that out a priori without making further assumptions. Okay? Because I don't know how to punish the 1. Because I don't know if it's the type who wants a high action or the type who wants a low action. Right?
Doesn't it depend on, I mean, if you have monetary transfers, can't you just take a lot?
Oh yes. If I have type-independent preferences in any form, which would include if I have monetary preferences, yes.
Well,
But I'm not assuming. But this is a general. This is
If you have a punishment that is
uniform for everybody. Yes. But I'm
That's weaker than type independent.
true. That's weaker than type-independent. It's just the ability to punish. It's a type independent. There has to be a type-independent coordinate of preferences, such as transfers. The reason I'm not thinking of transfers is in most of the models I'm going to be talking about, there aren't any. But yes. Just one second. As an aside, why haven't I been talking much about transfers? The reason I haven't been talking much about transfers is if there are transfers, then we know how to use them to elicit private information in mechanism design. So the focus in the mechanism design with evidence literature is on environments where there aren't transfers to ask how evidence is used. If we have both evidence and transfers, then there'll be an interplay of the 2 forces. And I'm not saying that's not interesting, but first it makes sense to ask what can we do with evidence when we don't have the usual standard methodology of eliciting preferences using transfers. Okay? So that's why I wasn't thinking of that, but absolutely. If I have transfers or any other universal punishment, I can restrict attention to maximal evidence for some type. But still, I'd have to write here m star of t double prime for some t double prime. Okay, there was a question in back.
You don't need a universal punishment. You just need punishment that is good for any group of people that can.
Yes. Exactly. Okay. So, let's leave it at that. So, what is a direct truth-telling maximal evidence mechanism? It's a mechanism which is direct. In other words, there's a cheap talk report and piece of evidence sent, a possibly random choice by the principal, such that announcing your true type and sending your maximal evidence is incentive compatible. Okay? If the preferences are type independent, then we can restrict attention to mechanisms that don't depend on, I think that's, wait, did I get it backwards? Yes. Then we can restrict attention and write this in terms of Q of t and assume that the maximal evidence will be sent. And if it's not, and if the maximal evidence of that particular type that is announced isn't sent, we give this uniformly bad punishment. So if we have transfers or type-independent preferences, or we can weaken this and assume various subforms of type independence, then we can restrict attention to mechanisms that say what I'll do as a function of your type, assuming that you present the maximal evidence of that type. So we can simplify the problem even further. Okay. What will happen if we don't have type independence? So now comes a time estimate. Will I have time to present this example or not? Elchanan is shaking his head no. Okay. I'll assume he's right, and if not, then I'll go back to this. But let me just talk about briefly what this is. So if you didn't have normality, then it is not true that you can restrict attention to such mechanisms. There is an alternative revelation principle which says you can do the following. You ask the agent the type, okay? Based on the type that he reports, you randomly decide what evidence he should present and send a message to the agent back. This is the evidence I want to see. Based on the report that you send, the evidence in the revelation principle mechanism, the agent sends back the evidence you requested, and then what you choose is again an action, a possibly random action, based on the report in the first period and the evidence requested that's missing here, and the evidence that was presented. Okay? And clearly, if he presents the evidence that is different from what you requested, you're going to do things that are bad for him in order to incentivize him to present the evidence that you want. So you need a much more general mechanism when you don't have normality. So in terms of Eric's question of what role does normality play, it means that the mechanisms you have to allow for are sequential, where the agent sends the principal a message, and then the principal sends back a message to the agent. Let me point out that if the principal isn't randomizing when he sends back the message to the agent, then that's redundant. Why? Because if the mechanism specified for each for each message report by the agent about his type, what evidence was going to be requested by the principal doesn't have to say it. It's just going to be defined by the mechanism. So if the principal did not randomize after hearing the agent's type, then that would be redundant. So the general class of mechanisms are such that the agent reports his type, the principal needs to randomize and does randomize. He says, I'm going to tell you which evidence I want, either this evidence or that. Okay? Intuitively, without getting into the details, why does normality avoid this problem? Because what the principal is doing when there isn't normality is a situation where I can either sing or dance. Okay? So I have two possible pieces of evidence I can present. I can't do both at the same time. We don't have enough time for that, or some physical other limitation is imposing that I can't present both the singing evidence and the dancing evidence. So what the principal is going to do, and let's say he wants to know if I'm the singer-dancer. So what the principal will intuitively, what the principal will want to do is he's going to say, I'll tell you later, tell me if you're the type who actually can sing and dance. If you're not, go away, I'm not going to hire you. If you're both, then I really want to hire you. But what am I going to do? I'm going to randomize over which one I ask you to present. Okay? If I told you in advance that I'm going to ask you to sing, then the singer could also always manipulate. If I told you in advance that I'm going to check you if you can dance, then the dancer would always hide. But this way you can do better by randomizing. Now, the example I gave is misleading because it's not enough actually to have two dimensions. In fact, you can prove that with 2 dimensions, randomization isn't needed, and therefore you don't need the more general. But with 3, you could do the same thing. And if I'm wrong, if Elchanan is wrong and I'm right, to which I assign 0 probability at this point, then I'll get back and show you the 3-dimensional example that presents that.
I was just going to point out that academic exams fit this secondary way. You want people
Yes.
to know everything.
Right. And you don't tell them in advance exactly
You don't tell
what.
them You're
Yes.
not going to test them on everything because that takes too long.
Exactly.
So you'll randomize.
Yes, exactly. So we all engage in in mechanisms that don't satisfy this because of the time limitation on exams. Thanks. Very good example. Okay. So let me move on to an application of the revelation principle. Really, not of the revelation principle, but of mechanisms. Jacob Glaser and R.L. Rubenstein introduced the study of when commitment is of value. So a natural question to ask is, when is commitment valuable? Also, when is randomization valuable? And also some other questions Elchanan will talk about tomorrow. But a natural question in the environment of mechanism design is to ask, is the ability to make a commitment of value at all? Okay? There's two reasons you might ask this question. One reason you might ask this question is because whether or not there is commitment is really, we don't usually model it this way, but it's really endogenous. I can set up, a principal can invest and set up an environment under which he's committed. He can develop a contractual environment, or he can just say, this is what's going to happen. In the latter, there's no commitment. In the former, there is. There are costs to setting up the contractual environment. So we want to know whether there's any benefit to doing so, to know in what cases we expect to see people investing in commitment technologies, and in what cases we don't. Okay. So, in the environment with commitment, then the principal is choosing a mechanism like this, okay, and we're allowing for randomization. And as we said, the agent chooses what to report and what evidence to present. What do I mean by the environment without commitment? The environment without commitment that I'm studying here, one could think of other things, but I'm just thinking of the exact same environment without commitment. Namely, the agent sends a cheap talk message and a piece of evidence, and then the principal decides what to do. And I'm going to show that in some cases, there's no benefit to commitment in that situation. You could ask, why did I look at that game? Maybe if I allowed for the agent to send the principal a message, and then the principal to reply with a message, as was redundant here with normality, that still may be useful in getting rid of commitment. Okay? So if I were arguing that the negative result is the interesting thing, then that would be a concern. But I'm trying to focus on my emphasis is going to be on the positive result. In the following environment, we don't need commitment. In other environments, one has to ask, what does it mean to need commitment? What is the alternative set of games that you're considering? Okay? In the case that we're talking about here, that isn't a big deal. But in some other cases, which Elchanan Bart and I are looking at today, actually even what the right definition of the game that's without commitment, what that game is, may change the result. Okay, whether you allow that game to be more involved or just to be report types and send messages, and then the principal sees that and acts. Okay. To give a basic understanding of what's going on in this environment, let me give a simple example. So the seller is going to be one of 999 types. Okay, I'm misusing my notation because I haven't yet said what the evidence is, and mu is supposed to be a distribution over evidence and values. Okay. But as you'll see in a minute, it's fine. Okay, so the types are 1 through 9. Actually, no, sorry, I didn't abuse notation. Sorry, not yet. The types are 1 through 999. The distribution is the 1 through 998 all have probability 0.001, and the last type has double probability 0.002. Very simple environment. Okay. The seller wants the buyer to believe his value is high. So the value is equal to the type. V of t is equal to t. The evidence structure is very simple. The highest value type can't prove anything. Everyone else can either prove their type or say, just be silent and not prove anything. So this type can't say anything. These types can either be silent or prove whom they are. Okay? The principal wants to guess the true value. The loss function is going to be strictly increasing in how far off you are. This is a very simple example of a disclosure game that I started with. Now I want to talk about two different situations. One is the loss function is going to be quadratic, and the other it's going to be a -1 if you're wrong, 0 if you're right. Okay? So, let's consider first the quadratic loss case. Then I claim that by results I'm going to give you in a minute, and I will have that minute, the commitment has no value. Okay? But if the loss is 0 when you're right, and 1, so you get a payoff of -1 when you're wrong, so the loss function looks like, basically like this, if this is the type. Okay? You lose unless you get it exactly right. Then commitment has value. The example is meant to show you the subtlety of the question, when does commitment have value or not? It's basically the same environment, but the specification of the loss function is going to determine whether or not commitment has value. That there's no value to commitment in the quadratic case is going to follow, as I said, in a minute or two when I present the results. That there is value in this case is very simple to see. So if you don't have commitment, if you don't see any evidence, what's the principal going to do? The principal is going to bet on the type 999. Because 999 can never present evidence. And let's say some other collection of people in the equilibrium without commitment don't present evidence. It doesn't matter what the collection is. You have to guess right. All the other types have probability 0.001. Type 999 has probability 0.02. You're going to gamble on that type. So you're going to guess 999. If you're going to guess 999 when there's no evidence presented, in equilibrium, no one will present evidence. You're going to get it right when it's type 999 and wrong every other case. Okay? So your payoff is minus 0.998. Now you imagine the following commitment. You commit to guessing that the type is 1, the worst possible type, when no evidence is presented. And that's all you need. You commit to guessing 1 when no evidence is presented, and you commit to guessing the truth, guessing what is the evidence that's presented when evidence is presented. So if someone proves they're 7, you say 7, which is obviously what you want to do. So what's going to happen in equilibrium under this commitment, in response to this commitment mechanism? Obviously, 999 will present no evidence, and you'll get that type wrong, and everyone else you'll get right. So your payoffs are going to be, in this case, minus 0.002. The result of this example doesn't depend on the fact that it's discontinuous, doesn't depend on the fact that it's not differentiable. Okay, that just makes my calculations much easier. It does depend on the cost function, because as I just said, if it was quadratic, then you would get no value to commitment. Okay, but it's not that it's this stark. It does have to look something like this, but that's all that's needed, the loss function. If it's quadratic like this, then there's no benefit to commitment. And now let me describe what the literature has done. So, Glaser Rubinstein, as I said, opened the literature. They show that there's no benefit to commitment. And I didn't emphasize this, but there's also no benefit to randomization. What did they assume? They assume that the principal has 2 actions. They assume that the agent has type-independent preferences, a utility function from A into R. And they assume that the principal preferences may depend on the agent's types. Okay? And that's just not an assumption, that's just general. Okay? They just allow for any preference. Why do I call it an assumption? Because I'll talk about generalizing this in a minute. So this is the first paper in the literature. Itai Sher allowed for the case that there's multiple actions. Okay? What he shows is that in that case, what you need is a concavity assumption. The concavity assumption is the reason the quadratic that I made is concave. This function is not. That's why this function doesn't satisfy the Sher assumption and doesn't get and is a case where you have a value for commitment, whereas the quadratic does satisfy the concavity assumption, which I'm not saying in detail, but basically it's that the payoffs are concave in an appropriate sense, and therefore when they are concave, there's no benefit for commitment. And in a recent paper by Ilan, Sergio, not here, and Moti, they generalize this further. They first of all, they generalize this, and basically they generalize it in a way that is tight. It's not, since there are a bunch of assumptions, you can never prove, it's difficult to argue what tight is, but if you read the proof, you'll see that it's a tight characterization. They have a much more insightful proof, so I recommend actually reading that. And they also ask the question of what this game without commitment may have many equilibria, one of which is equivalent to what you get, what the principal gets. Is there a natural, quote unquote, that's open to argumentation, but is there a natural refinement that gives the equilibrium that is the best for the principal? And in their paper, they show that for a class of games, there is such a refinement and characterize it. And yes, I'm out. So this is the proof that I was going to give for the result. It's not too long. And we were discussing yesterday whether I should even include that in the slides. And
Yes,
I'm out of...
because now they can read it, because the slides will be posted.
Oh, okay. So then I should take out a lot of the crap at the end that's after the thank you. So tell the guy before he posts it to give me a chance to read. There's a lot of gibberish that I put at the end that I thought I might include and isn't proofread. Okay, so thank you very much.